one last slide here, and that would be on some information just regarding solids. Now, solids take on two different types of forms. They take on what are called crystalline solids or amorphous solids. Okay, and the difference here is that the crystalline solid has the arrangement where it repeats itself and it looks like a crystal. It's a very repeating pattern over and over again. Amorphous is where they're kind of randomly arranged. A very good example of the difference between the crystalline and amorphous solid would be sand and glass. Sand takes on the crystallized structure, the crystalline structure, where the sand particles, the silicon dioxide that's in there, creates this really nice arrangement that repeats itself over and over and over and over and over throughout the structure. Well, that would be in the crystalline structure. Now, if you melt it down and you cool it down quickly, right? If you heat it up and melt it, these particles are going to move past each other. They're going to slide past each other. And if you cool it down quickly, you can kind of freeze it in that moment, kind of like where the particles are not arranged properly. What you're going to end up with afterwards is glass, and that's how they create glass from sand. Is they just basically take and melt it down and cool it down faster, and you end up with glass. And you can see through glass as opposed to the solid crystalline structures. You can see that the very difference in the arrangement gives you something that you can't see through, like sand, to something that you can actually see completely through. All right, I'm not going to go through the chemistry of that, but again, where does that come from? The transparency of glass versus the opaqueness of the silicon dioxide or the sand has to do with the electrons absorbing the light energy. Okay, the light energy all gets absorbed here. In this one, the light just passes right through. Okay. Anyway, types of crystalline solids. One question they typically ask is, what type of solid would it form? It's very similar to the last string that we saw, the last, not string, but the last flow chart that I had. So again, we're going to start out with, is the substance a compound? And again, I misspelled element because I kind of copied off my original one. So anyway, is a substance an element or a compound? Well, if it's a compound, it's either going to be ionic or molecular. Again, if it's molecular, you would call it a molecular solid. Now what they're saying here, by the way, is that you're going to have a solid structure that is bonded together, and it's going to have this arrangement. We're going to always look at them as crystalline solids, right? We're going to say it's a crystalline solid that repeats itself over and over and over again in the set. So each of these solids that we're talking about, the point, all right, that crystal lattice point is going to be a molecular substance. So if we're talking about a molecular solid, the crystal point would be water. So water would be here, water is here. What's holding those two waters together would be the intermolecular force, hydrogen bonding. Now, if we're talking about an ionic compound, well, then we would have sodium ions here, then we would have chloride ions here. So the particles that we would have here would be ions, would be at those points along the lattice structure. For molecules or molecular substances, you would have molecules. Okay. Now, if it's an element, okay, or if it's an atom, right, if we're just talking about individual atoms or elements, then we ask ourselves, is it metal, nonmetal, or noble gas? If it's metal, then we say it's metallic solid. And at each of these points, you would have a copper, 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 copper. So what would be at this point would be a copper atom. Okay, a metal atom, whatever it happens to be. And if it's network nonmetal, we refer to this as a network covalent solid. That would be a carbon would be an example of that. You could say phosphorus would be an example. Anything that's non-metal, okay, anything that's non-metal and not noble gas, all right, then that would be a carbon, and obviously the arrangement changes. I'm not going to go into all the various structures and shapes that they can have, but there are obviously carbon would do tetrahedral, as we saw before. And then here you would have your noble gas. Now I'm not going to do hydrogen, but I'm going to do helium, I'm going to do argon, I'm going to do krypton. I'm not going to do hydrogen because hydrogen is really diatomic, and that belongs over in the molecular category. Okay, this is very confusing in the beginning for students to get this and understand this. I'm hoping that the way I structured this and the stuff we'll do in class will really help you. But the AP test is really kind of focusing more on this concept this year. We'll talk more about this in class, but that's pretty much it. So talk to you guys later.